Have you ever put on a pair of headphones, pressed a button, and suddenly the noisy world around you just disappears? The rumble of a train, the chatter in a cafe, the drone of an airplane engine, all gone. It feels like magic. How can you add something to your ears and end up with less? How can technology create silence out of thin air? It's not magic. It's some of the most clever physics you'll find in everyday gadgets. Imagine you're on a busy bus or a loud airplane. The engine is humming. People are talking. The road is rumbling. It's a wall of sound. You put on your headphones, not even playing music yet, and flip the switch for noise cancellation. Instantly, that low, constant hum vanishes. It's not just muffled like putting your hands over your ears. It's actually gone. The world feels quieter, calmer, and clearer. This experience is so common now, but it's based on an idea that sounds completely impossible. The solution to having too much noise isn't to block it. It's to add more noise. To understand this paradox, we first need to understand what sound actually is. It's not a thing. It's an event. It's a wave of energy. Think of what happens when you drop a stone into a perfectly still pond. Ripples spread out from the center. Those ripples are waves, with high points and low points. Sound works in a very similar way. A sound source, like a person talking or a car engine, creates vibrations. These vibrations travel through the air as invisible waves. These sound waves are simply areas where the air molecules are squished together, followed by areas where they are spread apart. This pattern of high and low pressure travels to your ear. When these waves reach your eardrum, they make it vibrate. Your brain then interprets these vibrations as the sounds you hear. Every sound wave has a shape. Just like the ripples in the pond, it has high points called crests and low points called troughs. The height of the wave's crest is its amplitude. This determines the volume. A loud sound is a tall wave, and a quiet sound is a short wave. The distance between each wave is its frequency. This determines the pitch. High-pitched sounds have waves that are very close together, while low-pitched sounds have waves that are spread far apart. So every sound in the world, from a dog barking to a symphony orchestra, is just a complex combination of these waves hitting your ear. The constant drone of an engine is a very simple, repeating wave. Now, we get to the hidden problem. How do you get rid of a wave? You can't just grab it. You can build a wall to block it, which is what regular, non-powered earmuffs do. But some of the wave's energy will still get through. To truly eliminate a wave, you need to flatten it completely. You need to turn those crests and troughs back into a flat, still line, just like the pond before you threw the stone. What happens when two waves meet? Imagine two identical pond ripples moving toward each other. If the crest of one wave lines up perfectly with the crest of the other wave, they combine. The result is a new, much bigger wave. The high points get higher, and the low points get lower. In sound, this would mean the noise gets louder. This is called constructive interference. But what if the waves are out of sync? What if the crest of one wave meets the trough of another? This is the secret. When a high point meets a low point of the same size, they perfectly cancel each other out. The high point pulls up, the low point pulls down, and the result is nothing. A flat line. Still water. This is called destructive interference. And it is the engine behind noise cancellation. Your headphones are masters of creating destructive interference. Here's how they do it, step by step. First, there is a tiny microphone on the outside of your headphone. Its only job is to listen to the world around you. It specifically listens for those constant, low-frequency sounds, like the hum of a jet engine or the rumble of a train. It captures the sound wave of that unwanted noise. This information is then sent to a tiny but very powerful computer chip inside the headphone. This is the brain of the operation. In a fraction of a millisecond, this chip analyzes the incoming sound wave. It determines its exact shape, its amplitude, and its frequency. It knows the exact pattern of its crests and troughs. Now for the brilliant part. The chip creates a brand new sound wave. But this isn't just any wave. It's a perfect inverse of the noise wave. It is an anti-noise wave. Everywhere the original noise wave has a crest, the new anti-noise wave has a trough. Everywhere the noise has a trough, the anti-noise has a crest. It's a perfect mirror image, flipped upside down. This newly created anti-noise wave is then instantly played through the speaker inside your headphone, the same speaker that plays your music. So two things are arriving at your eardrum at almost the exact same time. First, the original unwanted noise from the outside world that leaks into the headphone. And second, the precisely engineered anti-noise wave being produced by the headphone's own speaker. And what happens when the crest of the engine noise meets the trough of the anti-noise? They cancel out. What happens when the trough of the engine noise meets the crest of the anti-noise? They cancel out too. The two waves destroy each other right at the entrance to your ear canal. The result of adding this second sound is the absence of sound, silence. The speed at which this happens is astonishing. The system has to listen, analyze, invert, and produce the anti-noise wave in less time than it takes for the original sound to travel from the outside of the headphone to your eardrum. This is why noise cancellation works best on steady, low-frequency sounds. They have a simple, predictable wave pattern that the chip can easily analyze and counteract. Sudden, complex sounds like a person shouting or a dog barking are much harder to cancel. Their wave patterns are too irregular and change too quickly for the system to create a perfect anti-noise in time. That's why even with the best headphones, you might still hear some of these sharper, higher-pitched sounds get through, even if they are muffled. But for the constant drone of modern life, the technology is incredibly effective. It's a non-stop, high-speed battle of waves being fought right inside your ears. The headphone is constantly listening and adjusting its anti-noise signal hundreds of times per second to make sure the cancellation is perfect. So when you're playing music, the headphones are actually producing two sounds at once, your music and the silent, invisible anti-noise that keeps the outside world at bay. It's an amazing combination of physics, electronics, and audio engineering. It takes a fundamental principle of the universe, wave interference, and packs it into a device you can hold in your hand. So here's the big insight. Noise-canceling headphones don't create a bubble of true silence. They can't remove sound energy from the air. Instead, they perform an incredible trick on your perception. They create a carefully crafted illusion of silence by adding more sound. It's a perfect example of how engineering solves problems in clever, counterintuitive ways. The problem was too much noise. The solution was to add just the right kind of noise to make the first one disappear. This technology is using a fundamental law of physics as a tool, turning a disruptive force into a constructive one by making it destructive. It's fighting noise with noise. The entire process can be boiled down to three simple steps that happen almost at the speed of light: listen, invert, and cancel. A microphone listens to the noise. A chip inverts the wave, and a speaker cancels the original sound before you can even hear it. It's a beautiful, invisible dance of waves. So the next time you put on a pair of headphones and the world goes quiet, remember what's really happening. It isn't magic. It's science, turning the simple physics of waves into your own personal pocket of peace.